Hello everybody, today I'm going to explain the solution to the third problem from the 2025 USACO January contest in the Silver Division, the problem table recovery. In this problem, we are given a grid of size n times n, which at the beginning has a very specific pattern. So for every position, we have the value r plus c, where r is the row and c is the column. And LC can perform operations first of the type 1, swapping two rows, then swapping two columns, and then at the end selecting values from A and B and swapping them between each other. And now we want to find a possible state of the table after operations 1 and 2. And we want the state to be the smallest lexicographical one. And now, in order to approach this problem, we need to first analyze some things about the initial table. And if we look at it, every value there shows up 1 time, 2 time, up to n times. And if we think at the frequency of the frequencies, every frequency has a frequency of at most 2. And what I mean by this is that, for example, 2 and 6 show up once. And there are only two values which show up once. And similarly for 3 and 5 we can see the same thing, while for 4 it shows up only, there is only one value which shows up n times. And then what we do here is that we will have this sort of, let's say, idea where we can think at what happens after the first two types of operations. And if we look at the first row, then the first row, after swapping two rows, the values there will stay exactly where they were. However, if we swap two columns, the values will still be on the same row. So the values which will be on the same row with, let's say, the top left corner, will always stay there, even if they are in different order. And because we only have two values which show up a single time, something we can think of doing is fixing the true values behind the aliases of the values which were in the same place with the value that showed up once. And the reason why this is so important is because in this sort of grid, we will have at most 2 times n distinct values. Actually, we will have 2 times n minus 1 distinct values. And because of this reason, we will be able to fix the n values from that row, and then every other value can be uniquely deduced. And basically, now if we try to do this for every single one of these two values which works, then what we can do is that now the only thing we need to check is whether any or both of these grids are valid as per the operations we obtained, and if so, which grid is the smallest lexicographical one. And if we think a bit about the way the grid evolves, because all values will hang over the same columns, then it is guaranteed that we will have a valid answer, because they say that the answer exists, and we already proved that the values on these columns will stay in the same place even if they change their relative order between the row or the column. And now all we have to do after these steps is to simply check for the two grids we created which one is the smallest one. And after that, all we have to do is to print the smallest one and we are done. But before that, I want to add a bit more context into generating the grid. So, for example, if we have a grid which is a square grid, then if we think of the positions that show up only once, so let's say we could have one here and one here. If we assume that this is where the 2 shows up, let me write it with another color, let's say with red. If we assume that this is where 2 shows up, we can have a permutation of all values from 2 to n plus 1. So we can have, let's say, 5, 3, and 4. And these values might show up in other places in the grid too. It's not super relevant because everything is going to be uniquely determined. And for this other value, where we would know that 2 times n shows up, so 8 in this case, we will once again have a permutation of the values from 5 to 8. So they can be, let's say, 6, 5, 8, 7. And because we already know now the true value behind the aliases, we can already construct these other positions based on what we deduced. So again, the coloring is uniquely deduced after we fix one row or one column. And all I had to do now in my code was, after a bit of observation, actually, the way I observed this is by actually just trying to place D2 in one of the positions together with everything else and just see where that leads me. And then I realized that I got most of the test cases. The test cases are a bit weak for this problem. And then after doing that, I just expanded for the other case, and with some more work, I managed to get it done too. So this is what I did here as well. I coded out the frequencies. I checked for every value from 2 to 2 times n whether it was used or not. Here in this part, I find the row, the first row with the frequency, which has the value with frequency 1. And then I uniquely colored everything there, everything else there. And then after that, I did the same thing for everything else in the grid. And here in the original code, I only had to check whether this value is at most n plus 1. However, I suspect that the test cases are a bit weak, and I should have had to write a function which actually compares value by value and check if the grid is smaller or lexicographical than the other one. But it worked in the contest, so I'm not gonna change much now. And we will go through the values in the grid, print them. Otherwise, we will print its symmetrical version. So every value is symmetrical with its other value with the same frequency. And after doing that, this is enough, and this gave me the full score as I finished this contest in a reasonable amount of time. In this problem, we had to be careful about finding some initial observations and trying out random stuff on the paper. And after finding the fact that every value's frequency only shows up twice, we can think of deducing the values gradually and then checking out the potential answers. If you enjoyed watching this video, please like the video and share it with your friends and subscribe to the channel, as I will continue uploading USACO videos during this season, as you've seen in December, and also now with the videos on bronze and silver. And also, if you or anyone else you know is interested in working more closely with me, please check out the links in the description for ways to join my tutoring program so that you can also achieve better and better USACO results. Last but not least, if you have any suggestions or feedback, I'm looking forward to seeing them in the comments so that I can improve my content in the future. Until the next time, good luck with the remaining 2 contests from this season, and I'm waiting for you in the next videos. See you soon and good luck. Cheers.